Hi friends, welcome to my channel. We are going to start exercise 12.2 question 1 without wasting any time. So we move on to first question. We have to express the given numbers in standard form. The first question is 0.0000. There are 11 zeros in fact. After the point decimal point 4, 5, 6, 7, 8, 9, 10, 11 and then 85. We have to express this in standard. So it's very simple question. I'm first going to tell you the steps how we can do it step by step, and then I will at the end I will definitely tell you how we can write it directly in a very short method. Okay. So first I will write how many terms are there after the decimal point. How many terms are there? There were 11 zeros and 85 two digits. So it's 10 raised to power 13. 11 zeros and these two digits 11 plus 2 13. So there are 13 digits after the decimal points. So therefore I write this as 85 by 10 raised to power 3. When I take the 10 raised to power 13 in the numerator, the sign is going to change. We are going to use this formula. So a raised to m, if it goes divided by 1 by a raised to m, then the sign of the power changes. Similarly, if any number is in the denominator and if we take it in the numerator, the sign of the power is going to change. Simple. So we have used this formula and now we have to write this in standard form. Standard form means writing the answer after one digit, give a decimal point after one digit. This is called as standard form. So after the first digit, this 8, we have to give the decimal point. For that, what we are going to do is, I am going to do this step by step as I told you, and then I will tell you directly also how we can do. 8.5, 85 can be written as 8.5 into 10, right? So I have written 85 as 8.5 into 10. This 10 raised to minus 13 remains as it is. Now these two terms 10 and 10 raised to minus 13, they have the same base and there is multiplication, so we'll add the powers. So it will become 10 raised to power 1 plus minus 13, that will be 10 raised to power 1 minus 13, that will be 10 raised to power minus 12. So it becomes 8.5 into 10 raised to minus 12. Now I am going to tell you how we can write this answer in short without doing lot of steps. So how we could do is, we'll do this step first, 85 by 10 raised to 13. Then we take this 10 raised to 13 in the numerator and the sign of the power is changed. And what I do is now, give the decimal point after one number, that is after 8, and as there is only one digit after the decimal point, consider this as 13, forget the negative sign, reduce this by 1. Why reduce by 1? Because this 8.5 is there, that is there is only one digit after the decimal, only one digit, so reduce this number by 1. Forget about the negative sign, just reduce the number 13 by 1, so it will become 12 and give the negative sign as it is. So this is your answer, 8.5 into 10 raised to power minus 12. So you get the same answer. Okay, let's see. It's not necessary that you have to understand all the steps in first example only. Okay. When I explain two or three more examples, I am sure you will definitely understand all the steps which we are going to do. I am going to take one question which is not in the book, but it will become easier for you to understand. So I am taking one smaller example. This is not from the book. So how I write this is, I write it as 582 divided by how many digits are there after the decimal point, 6. So I write this as 10 raised to 6. Now in the next step what I do is, I take this 10 raised to 6 in the numerator, so the power is changed. It's like this, sign of the power is changed. 1 by a raised to m was there. When we took it in the numerator, the sign of the power is changed. Now for standard form we have to give decimal point after the first number, that is this 5. And now what we do is, as I told you, how we can do directly, reduce the power by, how much by we reduce by 2 this time, because there are 2 digits after the decimal. So reduce the power by 1. So it will become 10 raised to power minus 4. How did it come like this? Let's see. How, if I solve it step by step, how will I do this? 582 by 10 raised to 6, then it will become 582 into 10 raised to minus 6. In the next step, what I will do is, I will write this 582 as 5.82 into 100. This 10 raised to minus 6 will remain as it is. 5.82 into 100 is 582. This 100 is nothing but 10 raised to power 2. This 10 raised to minus 6 is as it is. Now as the base is same and there is multiplication between them, so we have to use this formula, we have to add the powers. So when we add the powers, 5.82 into 10 raised to 2 plus minus 6, so it is going to become 5.82 into 10 raised to power minus 4. How did it get to minus 4? 2 plus minus 6 is 2 minus 6 and it becomes minus 4. But instead of doing all these steps, you can just remember a simple fact that you have to reduce the power by a number that is equal to the number of digits after the decimal point. So it will become very easier for you to solve. Let's see the example of the book now again. So we are going to solve the second question of the book. Question 1, second question. So it's 0 point, again there are 11 zeros, 4, 5, 6, 7, 8, 9, 10, 11 after the decimal point, then 942. So, how will I write this? 942 divided by how many digits are there after the decimal points in all? 11 zeros plus 3 digits, that is 14 digits. So, I am going to write 10 raised to power 14. Now, in the next step, what I do is take the power in the numerator. So, the sign of it is going to change. We are going to use this formula. Whenever we take any term from denominator to numerator or from numerator to denominator, the sign of the power is changed. Now, this is, I by mistake I wrote this as 9.42. It's 942 only. Now, I have to give a decimal point here. There are two numbers, two digits after the decimal point. So just subtract this 14 by 2. It will become 12 and give the sign as it is, minus. So this is the final answer. This is a simple example, simple method of solving the question. Instead of, if you don't want to do all the steps, you can remember it like this also. Let's do the next question of it also. It's question number 4. So it is question number 4 is 0 point, there are 8 zeros after the decimal point, 3, 4, 5, 6, 7, 8 and the number is 837. So I write this as 837 divided by how many digits are there in all? 8 zeros plus 3 digits. So that is 11 digits, 10 raised to 11. Now I take this 10 raised to 11 in the numerator, it will become 837 into 10 raised to minus 11. Now I give a decimal point here, so it becomes 10 raised to minus 11, and what I do is I just reduce the power again by 2 because there are 2 digits after the decimal point, so it becomes minus 9. This is the final answer. Now let's see, these all questions were of the decimal point, right? But what if a question is not of a decimal point? For example, this is not of the book, okay? Extra question. 5, 6, 2 and 4 zeros, not of the book. So how we can do this? This is even much easier. I can write this as 562 multiplied by, I will just count the number of zeros in this type of question. There are 4 zeros are there, so I write this as 10 raised to 4. And only difference here is when I give the point here, this time I am going to add the power. So I am going to add the power by 2 as there are 2 digits after the decimal point. So it is going to become 10 raised to 6. How did I get this answer? Now I am going to tell this question, same question step by step. So let's see. It was 562,000. So it is actually 562 multiplied by 10,000 as there were 4 zeros. Now I can write this 10,000 as 10 raised to power 4. In the next step, I write this 562 as 5.62 into 100. It becomes 5.62 into 100 multiplied by 10 raised to 4 as it is. So this becomes 5.62 into 10 square. 100 is nothing but 10 square into 10 raised to power 4. Now as the base is same, we are going to add the powers here. So it becomes 10 raised to power 6. But instead of doing all these steps, just remember a simple thing. Write this as 562 into 10 raised to 4, and then if there are 2 digits after the decimal point, add the power by 2. The difference, keep the difference in mind. When the question was like this of the decimal point, what we did? We subtracted the power. Forget the sign, forget this sign, don't think about this sign, okay? Forget the sign. Just subtract the number 2, 11 minus 2 is 9 and give the sign as it is. And when it's a simple question without decimal point, add the power by 2. Okay. So now let's solve the last question of first question of the book. So 12.2 question 1 last question. So it is 3, 1, 8, 6 and 7 zeros are there. 4, 5, 6, 7. So I am going to write this as 3186 into 10 raised to power 7 as there are 7 zeros. So in the next step what I am going to do, I am going to write this as 3.186 and I have to increase the power by how much? There are 3 digits, so I increase the power by 3. So the answer is 3.186 into 10 raised to power 10. Let's take another question out of the book. Let's say 85000000. How many zeros are there? I have written 6 zeros. So I can write this number as 85 into 10 raised to 6. In the next step I give a decimal point here and there is only one digit after the decimal point. So I add the power by 1. So simple. Let's take one last example. If it's 7000, so I will write this as 7 into 10 raised to power 3 and this is the final answer because there is only one digit. So where to give the decimal point? Even if we give the decimal point, it will be like this only. 7.0 is same as 7. So this is only in standard form. It is already in standard form. So you don't need to give the decimal point. If you want, you can write it like this also. These both are same. So let's move to the question 3 first because it's similar and then we'll move on to question 2. Question 3 is like this only. Only difference is that they have given those things in some word problem type. So 1 micron, they are saying 1 micron is equal to 1 divided by 1, 2, 3, 4, 5, 6 zeros are there meter. So it's very simple. 1 micron you can write this micron like this also mu, or you can just write it as 1 micron is equal to, just convert this, it will be 10 raised to power 6. 1, 2, 3, 4, 5, 6 zeros. Then you take it in the numerator, sign of the power is changed, that's it. That's the end of the question, simple. 1 micron is 1 into 10 raised to minus 6 meter. Similarly, we will solve few more questions. Let's solve the second question. Its charge of an electron is 0. How many zeros are there? 3, 3, 6, 9, 12, 15, 18 zeros. My God. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 zeros. My God. 16. This is charge of an electron. Although the number of zeros are very large, the question is very simple. It's how many digits are there after the decimal point? 16, 3, 3, 6, 9. How many digits were there? 18 zeros and plus 2 digits. So in all 20 digits. Now when it goes to the numerator, sign of the power is going to change. So it becomes 10 raised to power minus 20. Now what we do is we write this as 1.6. Forget the sign of the power. Forget about this minus. Just reduce this 20 by 1. Because there is only one digit after the decimal point. So it becomes 19 and give the negative sign as it is. So this is the answer of the second question. So these questions are similar, it's just that they have given them in the word form. So question number 3, 0.00001275. This is the size of a plant cell they are saying. How will we do this? We will write this as 1275 divided by how many digits are there after the decimal point? There are 8 digits. So I write this as 10 raised to 8. And when I take this 10 raised to 8 in the numerator, the sign is going to change for the power. Now I give the decimal point after the one digit, and as there are 3 digits after the decimal point, so we reduce the power by 3. Forget about the sign. Reduce by 3 and give the sign as it is. So this is the final answer of the question. Now let's move on to the last question of this. The thickness of a thick paper is 0.07 mm. So what we do is I can write this as 7 divided by 10 raised to power 2, as there are 2 digits after the decimal, and it becomes 7 into 10 raised to minus 2. As the number goes in the numerator, the sign of the power changes, and this is already in the standard form because there is only one digit. So if you want to give a decimal point, you have to write it like this. 7.0 is same as 7, so it's same thing. Okay, so we'll first now solve question number 2 and then we will solve question number 4 also. So question 2, express the following numbers in usual form. First question, 3.02 into 10 raised to minus 6. Then we will move on to second question, 4.5 into 10 raised to 4. So first thing is you must have observed what is the difference between the two questions. The difference is in the first question the power is negative and in the second the power is positive. Let's first solve the positive power question. It will become 4.5 into 1, 2, 3, 4 zeros. Now I am going to multiply 4, 5. I am just going to write the digits, forget about the decimal point. 4, 5 and write the 4 zeros as they are. Now, how many digits are there after the decimal point? There is only one digit after the decimal point. So, leave the one digit from the right side and give a decimal point here. So, it is nothing but 45,000. These are the same. Point after point, decimal point. If you give 0 or don't give 0, it does not make any difference. How to solve this question? First one, I will first what we have to do is change the sign of the power to positive. For that, what I am going to do, I am going to use this formula. I am going to write this 10 raised to minus 6 in the denominator and its sign will change, sign of the power. So now it becomes 3.02 divided by, there will be 6 zeros. As we are dividing by 10 raised to 6, the decimal point will move 6 units to its left. Where the decimal point was, the decimal point was here, it's going to move 6 places to left. So first, second, third, fourth, fifth, sixth. So this decimal point is moved by 6 places to its left. So actually the point will be here now. It's not going to be here. So point is moved there and there is 0 again here. So this is the final answer. So this question is also very easy to solve. Let's solve few more like this. So let's take third question. It's 3 into 10 raised to minus 8. So it becomes 3 divided by 10 raised to 8. So we have to first use this formula, make the power positive by writing it in the denominator. Now as there are 8 zeros, where is the decimal point? Oh, there is no decimal point here. That means it's actually 3.0. So what we do is, as we are dividing by 8 zeros, 10 raised to power 8 is there. So shift the decimal point by 8 digits. The decimal point was here. So we have to shift by 8 digits. 1, 2, 3, 4, 5, 6, 7, 8. So we have shifted from here to here. Decimal point is shifted here and we will give 0 here. So that's the final answer. Now see, if I write 0.03 or I write 0.030 or I write 0.0300, it's the same thing. So even if you don't write this 0 or if you write this 0, it does not make any difference. You can write it like this also. These both are the same. No difference between them. Okay. So let's solve last question. We'll solve question number 5 of this and then we'll solve the last question of the exercise. So question 5. So it's 5.8 into 10 raised to power 12. So how will I solve this? It will be, I don't have to write this step, okay? 10, I'm going to write 12, 0, 0, 4, 5, 6, 7, 8, 9, 10, 11, 12. Even if I don't write this step, it's okay, no problem. Just move the point wherever it was 12 places to its right. You can do it like this. Or what you can do, just write 5, 8 and give all the zeros. 5, 8, give all the zeros, 12 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then think how many digits were there after the decimal point. There was only one. So leave one digit from the end and give the decimal point. The answer is going to be the same. Follow any one method. What was the first method that I told you? How can you solve this question? What you can also do is, the question was 5.8 into 10 raised to 12. So what you can also do is just shift this decimal point by 12 digits from this 8. So count the 12 digits. So I'm going to count the 12 digits now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we are going to shift this by 12 digits and then give point and 0. As there is no meaning to this decimal point, this 0 after the decimal point, so it's okay if you don't give this, if you don't write this at all. So if you write this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 zeros, 5, 8, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 zeros, it's the same thing, no difference. Okay, so let's move on to the last question of the chapter. Question 4. In a stack, there are 5 books, each of thickness 20 mm. Okay, 5 books of thickness 20 mm. So, what will be the total thickness then of the 5 books? Therefore, total thickness of 5 books will be 20 multiplied by 5, that is 100 mm. Okay, and then 5 paper sheets, each of thickness 0.016. 5 sheets of 0.016 mm thickness. So therefore total thickness of sheets will be 5 into 0.016. Forget about this 0.0. It's 16 5s are 80. Now just count how many digits are there after the decimal point. It's 3 digits. So leave 3 digits from the end. 1, 2, 3 and give the decimal point. So it's 0.080 mm. So now the question was, what is the total thickness? So we have to write the total thickness of the stack. So total thickness is 100 mm for the books and 0.080 for the sheets of paper. See how we have added, it was 100 only, there was no decimal point, and in the second number there were 3 digits after the decimal point. So I have written this as 100.000. We have to write the decimal point one below the other, always remember this, and it's becoming 100.080 mm. Now, if you want to write this in standard form, how will we do that? Standard form means we have to write the answer like this. If the answer, any answer, I'm going to write this one only. If it's like this, we have to give the point here to make it in the standard form. Then it becomes standard form. So how I can write this 100.080 mm? I have to write this as 1.00080. For that I will have to multiply this number by, I am shifting it two places to left. Okay, see how can I write 56.8 as 5.68 into which number? What do you think? 56.8 can be written as 5.68 into 10, because if I multiply it by 10, the point will shift one digit to its right and I will get the answer 56.8. Right? For example, if it is 2.567 or 612.567 and I want to shift the point here, I want to write this as 6.12567, then I have to multiply this by 100, so that when I multiply by 100 the point will be two places to its right, so it's going to be the same. So for this I am going to write, multiply this by 100, and what is meant by 100? 100 is going to be nothing but 10 raised to power 2 mm. I hope you have understood the question. If you have any confusion in any question, please feel free to give your comments in the comment section, and I am definitely going to answer all the questions for you. Please subscribe to my channel and share my video and my channel with your friends. Please go through all the videos. We have taken 5 videos now for this chapter 12. Okay? Thank you so much for watching. Bye bye.